Okay, so we are going to continue our multi-threading topics. So today we are going to start a class. We basically more discuss about the theoretical part. What is the locking and how Java each object have own lock, and if as a programmer we want to ensure that one object at a time only one thread can use, we have a mechanism we can do. But default programmings in a Java support any object, any method can be accessed by any number of thread at any point of time. This is the default behavior. But sometime our business use case, our situation, our scenario where we have to control, no, this uh, business logics, yeah, this code not allow more than one thread can access, right? So these
Right.
theories study we discuss detail. So let us look at some example, some run the code. And yesterday we discussed two approach where one is the synchronized keyword, another is the lock edge interface. The two basic implementation where we are saying uh, asynchronous communication or shared resource control mechanism, right? So sometimes you can say multi-threading or sometimes say asynchronous communication also is a synonym, you can say asynchro communication. Sometimes this terminology we can use, right?
Right.
So here synchronous or asynchronous, what do you mean? So let's understand, right? Sometime whenever you are reading maybe YouTube or some online video tutorial, there are sometimes this terminology also is synchronous communication and asynchronous communication and synchronous communication. This kind of terminology also we have to read, listen, watch while the concept of multi-threading. Multi-threading is the way which we achieve this asynchronous communication, right? So we can achieve asynchronous communication via multi-threading, right?
That's right.
By default, whatever the code we are doing, our writing method, by default, all are the you can say single threaded applications. Okay, not a multi by default, single threaded, single threaded, single threaded, are sequential programming, sequential programming model, sequential programming model. Clear? So let's clear this concept, because whenever we are learning, we are reading in a book on YouTube, lots of terminology used. Sometimes you confuse what the meaning of this, what the meaning of this, right? So let us understand. First, understand. Already we understand what do we mean multi-threading. What do we single thread? Single thread means uh, one person are doing all the job, right?
Right.
Multi-threading means multiple persons are doing the same work or part of work, right? So as a human perspective, whenever talk about the single threaded or synchronous communication, that means the only one person or one threads are doing all the job. So whenever one person, that means they are doing sequentially first one task, two tasks, three tasks, four tasks, five tasks, 10 tasks, done. Then second it is done. So this is known as a sequential programming model or single threaded. Means ki one thread start or one process start, and whatever we define sequentially, whatever the instruction we written code, or maybe we write another method here, M1 method. So whatever the M1 method code written, sequentially complete. And here let's say I call M2 method, right? Another methods. So whatever written inside the M2 method, sequentially they are calling, right? So what do you mean sequentially? Our one thread start doing this job, then this job, then this job, then this are equal. Again go here, and from here start with this job, then this job, then this job. After this, after complete, again come back here, right? Again next line execute. Again you can method. Again go here. Again the first line, second line, third line, fourth line, fifth line. Again done. Again go back here. Again completing, and then say finally done. So this approach known as a your single threaded application, right? Or
Right.
sequential programming means ki all the execution of code going sequentially, right? So this is
Right.
known as a sequential programming or single threaded application or synchronous communication. Sometimes this terminology also synonymally used. So let's understand the meaning of uh, what do you mean by synchronous communication here? Synchronous communication means uh, communication means we have a uh, a party or a person real life and we, okay, whenever I am going to talking to you, okay, that means you must be present so that I can talk to you and you can respond to me simultaneously, right? This is known as a synchronous communication. You are telling something, you are getting a response, right? The same times you are asking question, you are getting yes or no ka response, right? That means synchronous communication means sequentially. I am asked A receive and A response. So this known as a synchronous communication. All about the talk going on, telephone call going on, client server architectures. That means you are going to ask, you are asked some help, and for addressing your problem, addressing your question, someone be ready to reply, right? This is known as
Right.
a synchronous communication, right? And sometime we are doing communication via asynchronous. Asynchronous means maybe good example, right? Email. I am typing one email to you, right? An email I send you, but I maybe at the same time you will be available to receive my email, or maybe you are not available at that time, or maybe at that time you are a leave, maybe you not your start your computer, or maybe you are not on your mobile, right? So might be I send my email to you, but at the same time might be you're not receiving, or might be you're not responding, right? Whenever maybe next day I come and open my email box, oh, I receive an email, oh, let's reply them, right? The same thing here also happen. You are asking something via email, someone received the email and again reply back. So here what the change means ki party A are sending message, but party B are not ready, are not started, still you are able to send the message, right? For sending my message, I am not dependent on the other party, right? Other party might be available or not available. Other person might be available, not, but I am successfully able to send my email and I am doing my own work. I am not waiting to your reply at the same time, right? So such communication known as a, that means a party a person are sending chat message to B party. So might be you are sending me, hey, WhatsApp message. Hey Ajay, how are you? Right? Might be I am not on the phone at time, on the mobile. So still your message is delivered, right? You are not blocked. You're not waiting, hey, someone come online, then I can send the message, right? It is not a case. That means
Right.
your communication, just you send message and you can do your own work, whatever you have. Whenever this party come online and receive your message and read something, again reply back, right?
Right.
So this communication between A party and B party happen not synchronously, means asynchronously. That means ki at this time, whenever they are sending, maybe you are available or maybe you are not available. still this is able to send the message to you. So this is known as a asynchronous communication. Good example, whenever I am sending the email or SMS or chat or WhatsApp, for all these communications, other party is not mandatory to available to be online, right? The person who are sending, that must be available on an online, so that they are sending, right? But other party which are receiver are not required to be online or to be available for respond, right? Is it clear?
Yeah.
But in the case of our server client architecture or maybe phone call architecture, so whenever a party are calling to me and I am not available, the communication is not happen. We cannot say anything. Or maybe I'm sending a, hey server, give me some response. If server is not ready to respond, you can say your request is bad, server is not available, your communication is stopped, not possible, right? Because for synchronous communication, both sender and receiver would be available at the same time when the communication going on. So is it something clear what is asynchronous communication and what is the synchronous communication? Any confusion? Any question?
Synchronize is you don't need to be present.
Uh, Synchronization need to be present. Both party need to be present.
Hmm.
Asynchronous, other party optional.
Like a phone
Receiver,
message. Like a
yes,
phone message.
yeah. Phone message, WhatsApp, email. So whenever such communication happen between A party and B party, so think question. Whenever I am sending one message to you, you are not online. So where my message goes, right?
Hmm.
Because as I type some message and press the send button. My responsibility done. My message is sent. But the person which I am writing to you, but you are not online. You are not receiving my message, right? So where is
Right.
my message? Because as a user, I am send my message. As a user, you are switch off your mobile, right? So question is that where my message goes? Who will taken care? That is known as some middleware, right? Some middleware are receive your message and store for temporary on his some space, right? Whenever you on switch on your mobile and whenever you connect your WhatsApp application, at that time you are receiving message from this temporary middleware storage location. You are not getting message from this person at that time, right? You are getting message from your middleware or WhatsApps or server. Hey, whenever you online, we are associated this software. This software, no, already for you, already I'm receive one message. So whenever you open, by default, this message are transferred to your message box, right? And you are able to see, hey, new message received for me. So at this time, actually, you're not receiving message. This message may be sent by 2 hour back, 3 hour back, 1 day back, right? So a message can receive by another party in the not synchronous is asynchronous. Is it clear how asynchronous communication happen due to the some middleware?
So middleware is like what is middleware?
Middleware, any server, any machine, any
Oh,
space,
okay.
any postal box. Let's example, good example. In a before the internet era, email era, how we are sending the messages by letter, right? A message as a party A, I write my letter on the paper, eh, and
Yeah.
put the envelope, right? And write the address and just go and put in the postal box, right? And after that, my work is done. But this postal box, complete postal chain of responsibility, according to the address, they are going to the find out a specific person and deliver your parcel, deliver your email, right? So same thing here, our middleware means your postal office. Okay, Sender
right,
send message to the postal office, and postal office is responsibility to deliver those mail or deliver my letter to recipient person, right?
right, right,
Similarly, nowadays in the kind of WhatsApp, whenever you type any message, first type message and decide which person I'm going to send, right? Recipient
right,
address, right? Recipient address means your name, right? So I am going to send my message to your mail. So look like in the case of letterbox, I write my message and also on the envelope I am mentioning the address name. This is the person, this is the address, this message, this letter goes, right?
right,
Similarly, in kind of nowadays WhatsApp, yeah, messages, yeah, email, you type your message and send the recipient name. Hey, this is the email address I want to send, right?
right,
So this information is received. Let's keep in the case of Gmail. Gmail server is the middleware. You are sending a Gmail email to me at the times you are writing the message are sending to me at that time I am sleeping, right? So your message is temporarily kept by Gmail server, right? Once I open my Gmail on the next day and I go to the inbox and check. So whenever I am opening inbox, that means middleware know कि, hey, now this person, this recipient available, I am giving this message to her inbox. So in my inbox, new email come, right?
right,
The same concept which traditionally before IT technology, before the internet era, the parcel, the letter, delivery mechanism happen, same thing translated in our internet, internet, our mobile, our technology, our computer, right?
right,
Clear? So this mode of means asynchronous, right? Means ki is this at this time a message, a person send message and start doing other work upon whatever they have next work, they are going to the next work. They are not waiting to you, you just reply me, right? Means he is
right,
sending message and again I'm going to continue my next work, next work, right? This person whenever receive something, he are receiving message and he again reply back whenever he done, right?
right,
The same concept happen in the multi-threading. Here thread, this is the thread 1 and this is the thread 2. Thread 1 just say, hey, this is the work done by the different person and send the request, and after that they are continuing his own work, continue his own work. So all the multi-threading communication or programming is considered as a asynchronous communication, right? That
right,
means our main thread have a doing some set of work. 1, 2, 3, 4, 5, 6, 10 line of work they have to do. So they have to do one here works. Let's key. I decided I want to send. So just he send, hey person, do your set of works, right? They start a new thread. And after that, just clicking. They are not waiting you completed or not completed. They are going to continue our next work, continue next work, continue next work, right? Maybe he reach here at this time. This time get a chance. This person come online and get a CPU chance, then start working, right? Maybe he have completed his work, still he is in progress, right? That
right,
means the both party are working but not the same time, not the waiting the quickly response, right? So this
right,
is known as a multi-threadings or asynchronous communication,
right.
right? So theoretically clear,
Yeah,
multi-threading or asynchronous communication. Asynchronous communication just like our email, just like our chat, just like a
right,
parcel, whatever delivery you are getting, all are the asynchronous communication example, right?
right,
And what the synchronous example, like all the phone call, client server architecture, right? Speech, study, right?
right,
At a time I'm speaking, you're listening. This is the synchronous communication. This mode means ki I am teaching you this subject and at the same time you are listening to me. So this communication is the s- synchronous communication. Other communication can be, I just recorded my video, I recorded my video. Once I done and I uploaded YouTube channel, right? And
Right.
after that you come and study them, right? So this is the same thing happen, but asynchronous. At the time I am teaching, at the time you are not studying, right? So this communication known as asynchronous communication. The same video which currently we are live studying, this is example of synchronous communication. But the same video, let's say I uploaded on a YouTube channel, and later one day, 2 day later, you can again watch the same video. At that time, still I am teaching and you are listening, but that is not a synchronous communication. That is asynchronous communication. At that time, I am not available to answer at the same time, right?
Right.
So these are the, so all the communication happen through YouTube are the asynchronous communication. All the communication have as a live conference, live chat, live online calling, online video. These are the synchronous communication.
Right.
So these two terminology clear. What do you mean by synchronous? What do you mean by asynchronous?
Yeah.
Okay. Synchronous means simple again. Both party are available at the same time. They are asking question and they are waiting for response at the same time. Right?
Right.
In the asynchronous communication, they are send message and forget and doing his work. Once he receive message and then maybe later reply. Right?
Right.
So always asynchronous happen between other something middleware. Maybe here our multiple threads.
Right.
So nowadays, lots of middleware application server might be Kafka, might be email server, might be message chat message server. All are the middleware servers, right? Lots of nowadays this middleware server playing very important role nowadays, right? In all the application generally most frequently use application using this concept, middleware concept, right? To communicate two party, to communicate two application.
Right.
Nowadays, in the era of microservices, this is microservice 1 and this is microservice 2. Okay, our application 1, application 2, they want to communicate to each other. The one communication, synchronous communication, right? This
Right.
application up, this application up, they are sending request, you are getting response, right? This is
Right.
known as a synchronous communication. One way other communication like event based means ki this microservice want to communicate to this microservice. What they say, they are writing message some middleware, maybe Kafka queue, Kafka topic, right? Hey, say ki this is the event I generated and this is listened by this microservice. They are say you are receiving something, I am do something, and after that again write data here and you again read from here, right? So this communication happen, maybe this server somehow down, they still they are able to write message and going to other doing processing, right? Whenever
Right.
this server going to up, they receive message and do perform and again reply. So in this way, what we receive, our application continuous base running. What happen if there is synchronous communication, they are trying to call and maybe this server going to down. So what you can do, just we have to wait. We cannot do further work because we are dependent on the response, right? The same time,
Right.
let us our Google server going to down, you are want to some search data, you cannot get anything until Google server is not up. So each communication have own situation where both are used. I'm not saying this is the bad, yeah, this is the good, yeah, this is the bad, this is the good. Both are communication use the different context situation. Is it clear?
Yeah.
So here we are not any emphasize कि single threaded application are good or multi-threaded application are good, or this is not good. Both have different use case, different scenario, right?
Right.
Sometime we cannot realize, maybe in the case of online, let's see, nowadays cricket match going on, right? So there is no any make sense. Let's now live gaming going on at the same time I want to watch, right?
Right.
It is not any make sense ki live video going on and later part I am going to watching. All the thrills, all the pleasures are lost, right?
Right. Right.
Sometime at the same moment, what player game is going on at the same time I want to watch, right?
Right.
I don't want to take any delay. This is normally just record them and later tomorrow I'll watch. Tomorrow you can watch, but the pleasure, the enjoyment of the next ball enjoyment, next ball the thrill, you cannot give because on the recorded video, you know already the result. You can move the mouse and whatever you want to watch, again go back, again watch. The pleasure, the enjoyment you cannot take, which you are taking in life, right?
Mm-hmm.
So all the live session, live recording, live online gaming, live cricketing is the example of synchronous, right?
Right.
And all the recorded video, all the material available. This is the, you can say something online and offline. Online means synchronous, offline means asynchronous, right?
Right.
So in the era of this technology, these two, synchronous and asynchronous, both are heavily used in the context and situation and scenario.
Right.
So if you are reading about multi-threading, so all the communications where required asynchronous, that means this concept are going to use, right? And the synchronous communication, all the things you are studying before the multi-threading, meant by the single threaded, all are the known as single threaded or sequential programming model. The both have a significant, both have a plus, both have a minus, both have advantage, both have a disadvantage, right?
Right.
So it's clear our objective multi-threadings are whatever the programming before multi-threading with the single-threaded or sequential model, both are use case depend upon our customer situation, requirement, condition, right? Any doubt till now? What do you mean by synchronous communication and what do you mean by asynchronous?
Yeah. No. Correct.
Okay. Great, because many times whenever I am study, recognize ki many times while calling the locking, multi-threading, this terminology I use asynchronous communication, synchronous communication. So today I think let's discuss on this specific point. We should clear what the meaning when I am talking synchronous, what the meaning I am talking asynchronous, right?
Right.
And how to correlate our multi-threading concept to the this synchronous and asynchronous terminology, right?
Right.
Good. So studies say whatever uh, say studies understand the object locking. Notice you use a synchronize keyword. Notice a synchronization word, same word as synchronize, right? Means ki something I want only one threads can do, right?
Right.
Due to that, the word as a Java language chosen synchronized keyword. We are going to start a synchronized keyword, right? Because this shared code, this module, this application, I want to execute it by a specific number of thread only, maybe one, maybe two, maybe 10, but not unlimited. Maybe not undefined, right?
Right.
So let us look some example, right? This is the theory part. Clear? In the multi-threading, lots of theoretical concept measure, right? Because the models of programming already you know how to write the program. This multi-threading just a flavor the way how you run your code, right?
Right.
So let us some example. What example to take? Uh, Let us good example can be already we have increment decrement already discussed, right? Last
Right.
couple of example, how one threads are incrementing, another also trying to say I'm not getting the same summation, right?
Right.
Sometime. So we can use the synchronized keyword. There are some multiple producer consumer problem. This is the one very common programming model or example generally used by this multi-threading. One is the producer, okay, one is the consumer. So here producer some data producing, producer data some produce, then consumer consume, right? If producers are not producing, consumers just wait, right? Might so here a good example, producer consumer is a very popular two model to implement this producer and consumer, right? What do you
Right.
mean producer consumer? This terminology many times in a maybe in operating system or maybe other subject and real life also we understand. What do you mean is a producer and what do you mean a consumer? By terminology also the producer means they are producing something, right? Consumer means they are consuming something, right? So this generally producers and consumers are two threads, are two peoples, for two company, two organization, right? If something I'm not producer producing, let's consumer is started and how consumer can consume something. All the possible scenario might be producer is first started and they are producing some data, okay,
Right.
and consumers may become late. So what happened about this data which they are produce? They are waiting for the next production or wait, hey, someone come and consume my data. Once I am free, I am going to put another data, right? In the case of maybe delivery system or pizza delivery, yeah, Amazon delivery, you can think anything. Let's say I, as a person, give any order, okay? I, as a person, I am given the order A. Now you receive order, but if order is not packed, not packed, not ready for deliver, you cannot send, right? Until you are not deliver or sender person, which are going to delivery man not going to start delivery until the package is not ready, right?
Right.
So sometime our different people, different channels, sometime they have to wait, right, for particular
Right.
conditions. One, until you are not given any order, let's say you given the order but till now I'm not given the payment, right?
Right.
Until this is condition, until you not completing the payment I cannot start the delivery process, right? So somehow you receive the order but still you are not going to start delivery process because you are not getting confirmation from a payment received, right? So once you payment receive, then you can say, hey, I received the payment, I have an order. Now let's I give in the instruction to the delivery packaging team. Hey, packaging team, can you package this item for a number of quantity and send for delivery, right? Delivery man waiting until I'm not receiving any deliver packed item, I cannot start delivery. So in a real life, all the time, sometime someone data producing, someone sometime data consuming. It's clear? The someone sometime we have to wait and someone sometime you have to wait also. Both maybe producer can wait or maybe consumer can wait, right? Depend upon the case, right? Like here might be sometime this person is waiting, sometime this person is waiting, sometime this person. Here person means thread. Person means one
Right.
application. Nowadays, here we talk about one talking thread. Nowadays, in the case of microservice, all these three are application. Payment is the one application, one microservice.
Right.
Order receive is the one microservice, one thread or one process. Packaging is a separate process. Delivery actually item is a separate process, right? So all are
Right.
the different microservice one, microservice two, microservice three, microservice four. Microservice four microservice mixed together and fulfill the one complete use case, right? So in the case of if multiples people, multiple microservice, multiple threads are going to work for a specific purpose, the sometime they have to wait, sometime they have to communicate, right? Sometime to wait, sometime to communicate, right? So these are the very common problem is basically known as a producer and consumer problem. Okay, so let us try to understand. We are going to write one. Here I'm not going to write a microservice, but just example. Let's say I'm going to write one thread. Thread 1 is responsible to producing a message, right?
Right.
Thread B responsible to receiving those messages. Simple. And our case, let's given one condition. If producer have already produced one message, and until consumer not consume, I'm not going to produce another. Let's assume my consumer has a only capacity to consume only one message, right? Let's produce a thread are producing one message. They have a capacity they can going to produce another.
Right.
So they have to wait until consumer not consume a message, right? Once consumer consume a message, then I can say I'm going to produce the next one, right? So this is a good example of your multi-threadings. Here the shared resources, synchronous communication, and asynchronous communication. To clear the problem, what we are going to solve?
Yeah.
So in the case of multi-threading, now always we have to first understand the situation and then decide how I'm going to write the code. Right? It is a clear?
Yeah.
So let's do. This example, I am just write my producer. It's a very, very common example in the multi-threading environment, right? They are fit in the real time, many almost different part of the, you can say, supply chain system. Whatever where the supply chain system going on, this producer consumer problem fit, right? Means or the particular objective is met by the multiple steps, right? Process, producer, sorry, producer. This is the one, maybe producer is the uh, producer is a thread. So let's say started we can write the thread using the extend. I can implement, right? Implement runnable. This we are trying to say producer is a one threads that are producing some data, right?
Right.
So whenever you implement runnable, you have to override this run method because this runnable is a functional interface. They have a one run method, right? So let's say I say, hey, I'm going to implement this method run, right? So now producer is going to producing data, right? One thread say, hey, south.
And what is the reason again we implement runnable? Because that's
I want this my code run by thread because why?
Hmm.
Here producer is the separate one person, right? And consumer is the one separate person, right?
Right.
Consuming message. So there should be only one thread cannot become a producer and consumer both, right?
Right.
There is no case. Due to that, I am going to write one is the one thread for producer, one thread for consumer.
Right.
They are going to produce some data and they are going to consume some data, right? Is it clear?
Yeah.
Objective is that. Due to that, I am going to write a thread. So writing a thread, we have discussed multiple approach, just a revision section. By
Right.
extending thread class, by implementing runnable class, or executor service, right?
Right.
Or you can run any method and just use the thread class, right? So multiple
Right.
approach, just any yesterday I write the thread class using the extend implement and the just today runnable. We have a multiple tools. You can use the different tool so that you make a familiarity, right?
Right.
So there is no any specific purpose. You can use the extend class, anything, right? So let us see. Oh, sorry. So here say producer, producer, uh, thread started. Okay. So thread name. Okay. Thread name is okay, current thread dot get name, right? It's just mention processor thread started. The name is okay. Name is okay, whatever the name. Okay. Simple one thread. This is the producer thread. So this is the this simple class, but it can become a thread. We have to use this multiple approach. So similarly, let's one consumer class. So I'm going to create the two threads, right? One producer, one is the consumer. So in the case of multi-threading, always we have to give the name as your context, as your situation, right? Consumer, right? The naming is the very important in the multi-threading, right? So once someone reading this problem, understand your producer is doing, producing something, consumer is there going to consuming something, right?
Right.
So now this is the two threads, right? Till now there is no so still if you run in the main method, you cannot start it. By default, there is limitation. These two threads, they cannot start automatically independently. So we always have to take the help of your main thread. In a Java programming language, or you can say any other programming language, always have a one main application, say main threads are responsible to generate other threads, right? Because we as a programmer cannot directly talk to the operating system. Hey, operating system, can you start one thread for me, right? So
Right.
here, until I am going to take the help of, let's, this is my producer equal to new producer, okay? And here, let's consumer, consumer equal to new consumer, okay? Till now, still there is no kind of a threading, right? Because just you created a two class, you create the object. So I say whenever we are going to start thread, we have to hint Java virtual machine system. Hey, now here developer want to start this code done by the separate thread, this code done by the separate thread, right? So how do basic, go with the basic say we have to use the thread class, right? Thread class equal to new thread, right? And here say thread dot start. What happened? Okay, I'm not mentioning semicolon. Semicolon. Here thread dot start, right? So we understand, but we have to say this is one thread we starting. So one thread what do? We have to say that you do as a work as a producer. So you can say this is the producer thread, right? This is the producer thread, right?
Right.
Yes, mention. Similarly, let's one consumer thread, right? So this is, hey, this is the consumer. So this is the consumer thread, right?
Right.
In this way, we have to start. At least now we requested, hey JVM, can you start two threads, right? And let's main come here say s out, okay, main main thread, okay, main thread dot current thread dot name, okay, main thread done, right? If you run this code till now, I'm not putting any intelligence, just this is the one liner code till now, okay? Just we are first setting infrastructure key, what we are going to do here, what we are going to do, just I'm created one simple thread, just I'm created another simple thread as of now. Whenever I am run started this thread, I am started this thread, right? They
Right.
are just printing one message, they are printing one message as of now. This both threads are started by my main thread, right? Main thread. So this main thread also thread 1, thread 2, thread 3. So at a time, 3 threads are going to run in my machine, right? So let's run. So slowly we are going to understand how we are going to achieve. I'm not going to write all code in the one shot, right? Just understand it step by step. No notice, this is the main thread and this is the thread 1. This is, I can give the name producer thread, consumer thread, right? I can give the name as well as here. So how to give your name as a pass here? I am producer thread, I am consumer thread, right? Here you can pass the name as well, right?
Right.
Let's not do, but we can do here pass the thread name, and in the constructor we can initialize. We can do, right? So as of now, here we have a constructor. I think maybe something like a thread name is in the constructor. Let's check. Here, group name, thread runnable, string name, thread class, thread group, runnable, and size. This is the thread name. We have a second parameter like second parameter, distinct thread. I think name. Maybe let's check second parameter here. Second parameter I can pass the thread producer thread, right? Always we have to check the API, right? Which thread have a
Right.
constructor. This is the and notice here I run here thread 0, thread 1, and let's run now. So notice name change here. Okay. So in this way, you can give your own name. By default, I'm not giving name. The by default thread 0, thread 1, some, right? It's clear how to give your name for the thread. Right? Notice this current thread dot get name method. They return which name, which I am set here, right?
Right.
Notice here I'm what I'm printing here. I'm say ki, hey system, hey Java virtual machine, whatever the current thread, give me the name. If I'm not setting this name, by default thread name underscore 0, 0, 1, 2, 3, 4 number of, right? So till now, any doubt, any confusion? We have created main thread created two thread. One is the producer thread, one is the consumer thread, right? So next scenario now it's at least we completed this part, producer thread and consumer threads. Now producer is producing data. So question, where producing going to produce data and where consumer going to consume data, right? There are some place where they are going to produce and consume, right? Is it clear?
Right.
So
Yeah.
somewhere we need some, this is the shared object. Okay, this is the shared object, means they have also to write data here and wait. And something also have a here, they can read data and inform, hey, I already read it. You can do the next. The first step, we need to decide some common place, right? Where this thread are going to write data and this thread is going to read data. Is it clear our use case?
Yeah.
Right. So here common data means shared object, right? Java object. Here here something in Java, each and everything object. So now they can say this is one is the object. Maybe data holder or data place where this thread are able to access this variable and write. The same variable can be accessed and read by this variable, right? So in the Java, actually I am going to create one object. Okay. Now for creating object, we have to need some class, right? Create a class and then create object. So I am going to write some place, some class where both threads have a same object. One can write and one can read. It makes sense? Any confusion till now?
Yeah. No.
No. So let's simple way. Simple. This is the my one data object, right? Data object, data class. Okay. This is the data, and just they have a let's simple. They have a integer variable like a data. Okay. Whatever the data have. Okay.
Right.
Our data value. Okay. Whatever the value. Simply. I have now just simple. Now this have a one value right here. It's clear. And so let us this is the like a private, and here say only get and set value, right? Someone can change the value, someone can getter and setter. Insert getter setter. Okay. So now it's data class clear. Data class have a one data variable. They have a some value and initially whatever the value. So now we have a one producer thread, one consumer threads. Now I created one data object, right? And now this data object I have to share here and I have to share here, right? so that they can write value or they can read value, right? This is our objective. So let's
Yeah.
say this is the data. Now I am going to hey, this is my data, data equal to new data. So this time created one object, means this is the common place, and I'm saying, hey, take you and take you both, right? So that both have this variable, both have this object. So that means this class need a constructor of data. So here say in this class we have to add data as a constructor, right? And insert constructor. But here notice compile time error, right? Because there is no constructor, right? Or you have options directly. You can say here also IntelliJ give option. Here go and say create constructor. So they create constructor, right? And
Yeah.
similarly for here also say hey create constructor. Create constructor. They create constructor, right? It. So similarly now we have this variable say this dot data equal to data. Because this data question is that okay, now this data variable here, how can access in my run method? Because run method going to write data, right? So this data
Yeah.
variable I cannot access here, right? Data dot set, right? We cannot do because this is the local variable here. That means this variable I have to declare outside here, and I am declaring this variable here and say ki whatever here say this dot data equal to data. Already we discussed why you are writing this. This means referring to this class variable. I am not, if you're not writing this, that means this local variable assigned to the local variable, right? So
Right.
due to
Right.
say, hey, this, right? Clear?
This means the
This
class
means
variable.
this variable. Now, whatever the here I pass like data here, so whatever the value pass I go here and this go to the set here, right? And now the run method are able to write data. So let's say here. So here, what say now? This is the producer. Producer responsibility to uh, data set value, right? Let's they are going
Right.
to the value set. Let's one. Okay, they are setting value one, and say like producer have a producer data. Producer head is plus producer data. Produce is produced data, right? So
Right.
let us good things we have to. Instead of this, I say okay, let's create one variable integer value value equal to let's one, and is a created let's value 100 a value, okay, and just say producer data and just like here bracket double quote plus plus. So here say कि now our thread producer thread क्या they have get some random number data and just setting the value. That means this is the my threads producer threads, and this is my consumer threads, and they have a one data part data object, and now this producer okay, hey I'm started and I'm going to write data here set value, I'm writing data here I one value, and now we have to wait so that this thread get go and read this value, right? Once this read they have to inform hey thread you can write more data next data, right? Our objective, so that I want these threads are communicate to this thread via middleware means ki asynchronous, right? So let's read. Now these threads are producer data. Let's if you run here as of now, as of now, okay, I have to okay, as of now just comment here. As of now, you notice producer thread is started, consumer thread is started, producer has a produced data 100, but consumer is not consumed, right?
Right.
So let's say, hey consumer, you already have a data and you just get value, right? Right? Look like here, give the same. here, say consumer thread consumed value, right? Right. So here say thread just consume and let's run. So now one data producer producing. Notice here. Notice consumer consume 0, but consumer must have consumed 100.
Yeah.
It's a problem somehow because we have not ensuring this is the producer thread and this is consumer threads. Okay, and this is your data. I started producer, I started consumer, but as per the thread life cycle, I don't know who going to execute first, right? Maybe I started this one, I started first this one, depend upon our OS scheduler, right? So what happen if they going to get a first chance, they are going to read data. And there is no data, so by default they are rating the zero value, right? And later part he come and they are going to set value. So notice this, they are getting reading data 0 and they are getting data 100, writing data 100. They are writing later, but consumer have a consume before, right?
Right.
So this is the problem. Let's run again. Might be consumer get a first chance. Until here, the notice now producer pursue data, but still consumer not consuming. So this is the we are not expected because this the shared resources and we have to need some thread communication here, right? Thread
Right.
1 and thread 2. Producers say I am producing and consumers say I am consuming. It's okay. But we have to add some more intelligence. I am say, hey consumer, you are until not getting some value, you have to wait. Don't stop. Currently, what happened? Our consumer thread are stopped. I am saying until you are not getting some value, you have to wait somehow, right? Maybe you can get a first chance, I have not control, or you can get less chance. But I have some mechanism. You have to wait until someone not write the data here, right? If let's this get a chance first, this get a chance first, they are going to flatly write the data. What happen next? Next time again same thread get a chance, again get the next value. No, don't write the next value because this existing written value like 100 is not consumed. If you write the new value, your old value is lost, right? So here we need the thread communication. One thread say yes I done, one thread say hey I'm waiting, right? Is it clear? Ki what is
Yeah.
the problem? This is the problem. All this is the problem of multi-threading. If someone written this code and read very clear, carefully say, hey, it's very fine. Producer data producing, consumer data consuming. There is no problem, right? Both are working the same thing. But if you run the output, you are getting some different output. Notice at that time, both are 100 value, right? Notice that means in this case, what happened? Producer first run and produce data 100, and consumer second run and consume data 100, right? You are getting the output is very different, right? Depend upon the which thread is started first, which threads are started later. So I don't want this. I want hey two threads. You are communicate to each other and decide. Okay. So one way I want say hey I want always my producer not producing only one data, maybe produce five data. I five data maybe consume here. So let us example here say in the case of producer, producer is going to produce maybe in the loop. Let's say while loop. Let's producer is it's a value. Let's greater than 110. Let's less than 110. 110. That means till now you produce the value, right? But say always not an issue. Here say once value plus plus, right? Here what say producer is going to pursue data 100, 101, 100 to 10, 100, 10 data, and consumer must responsibility to consume all the value, right? So here if you run notice producer have a produce data lots and consumer is a just consume only one data, right? 100. And producer have a produce all the data, right? 100, 101, 102, 103, 104. Consumer is not consuming, right? So let's also I say, hey consumer, you can also, so instead of this, so here say uh, the number of data they are going to write here. So as of now, let's here like a 5 or 10. We have to somehow this thread know ki how many number of I am going to run, right? I don't know how many number of I am going to read. One time, two time, three time, four time, right? There is no any option. So how to this thread know ki I have to going to read one data, two data, three data, or what? And surely our objective, once data one written and second data must be not going to written until this is not read. This is our objective because this data have a only possibility they have write only one value, right? Once they have write at the same time they have written. Once they have write second value, second time they have to read the value, right? So our meaning right. Is it clear something? So this is the problem we are not able to address. So here I know I can write the file loop, while loop, or something. How communication happen? I don't. I only know once this data written, they have to inform something. Hey, you can read. Just our objective is that these threads are write data at the same time. Hey, inform hey thread, you can do your value, right? It's clear something. So let's think how we can write this code. So here multiple approach, multiple things we can do. So let's go with the basic one flag. If let us good example, uh, they have some set flag. Hey, I have written value. You can go read something true or false something, right? If something were not false, maybe here like a case I'm explaining here, like we have to introduce some mechanism. Now this is your shared object. I am say to start a sake, if this is the my data, this is the value. If I am going to write data at that time, I have to just take the log. And once I take the log and write the value and then I release the log, then these threads are going to read the value and say, yes, I read. You can again inform, hey, let's go, you write another data, right? Are you okay? Are you here? Are you able to hear me? I think maybe voice issue. So let's think how we can address. Uh, are you not able to hear me? Hello. Might be some voice issue. Hello. There is any voice issue?
Can you hear?
Yeah, I'm okay. Okay, I'm thinking might be a voice is my voice is not going.
Yeah.
Okay, sorry. So we are middle of the problem, right?
Yeah.
So till now, we have to make some thread synchronization between that, right? So whatever the data they have, whatever this value, they are going to read and write, right here.
Right.
Someone reading, someone write. So at the same time, we have to inform this data object have some lock mechanism. At a time, if someone reading, the someone cannot going to write at the same time, right?
Right. Right.
So here, what I'm trying to say, if we have this data object, somehow we have to ensure that this is thread one say I am going to write data here, right? So first acquire the lock of here, and check, hey, I'm able to get the lock and write value, and just inform, hey, now you can go read. So how I can inform? Question is that how this thread say, hey, now I done my work, you go and start your work, right?
Right.
So somehow they have to inform. Yeah, set a, some here set a flag one flag. Let's initially flag some true. Let's they say, hey, I'm going to write data and say false. Until someone not true, I'm not going to write the next data, right? This is the one say this is the one flag. Initially let's false. If this say is false, yes, I am false. I am going to write data. Once write, it's going to the true. So this thread say, hey, it's true data. That means someone written a data. I'm going to read here. So this is one way mutual communication. So here might be maybe some let's uh, uh, flag maybe boolean. Okay, boolean maybe flag. What flag name would be uh, is read or write something, read flag or write something, maybe just flag one flag. Initial value let's would be the whatever the value initially by default is a false. So what do you mean false? Here they are going to the check. First they are going to the check. First they are going to the check while loop before this flag dot flag value is a false. Okay, let's say I'm saying this flag value is a false. Okay, then I am going to write data, and same flag I'm going to say here when while loop you say you said you consume data when it is a true. That means what I'm saying. If this once this data flag means false means initially by default it is the false, right? By default false means I want initially by default anything means false hota by default means my say our intention wherever producer thread say, and if say this is the false, that means you are going to write data. Means here say this is the one variable initially false, okay, and both thread come, this is the producer thread come and this is consumer thread come. Consumer say read this value false, this means now it is your time you write the data, right? You write data here. If let's this come first, if false, that means you don't wait, you're not doing anything, just wait, right, until you are not free, right? So due to that I here write right until you are not true, just wait. While loop means infinite loop, they are not going to the breaking until if this is the true, then print data and let go print next data print go next print data print go until you are getting a question is that in this way still if here let's not equal to. So here let's still we have a not solve the problem. So notice they are infinitely one in data producer producing, consumer is not let's I'm writing some here wait, let's give someone write data, and here I am not setting data to the once data written done, I have to set it should be like a true now, right? So I initially false, I write data and I said it's a true, right?
Right.
And so that consumer become a true and then going to read data. Let's read it. So notice what happened here. Producer purchasing and consumer might we get a chance consumer stop somehow. So notice again run here, again run here. Okay, that means now let's consumer started. What happened? Notice here there is no any kind of this data false. Next time they are not going to writing data. They are go outside of loop, right? So somehow we have to make loop this loop always run, right? What happened? This is the first. Go outside. Means here let's write thread is stop. So here say let's say it's completed. Here say it's completed. Completed. Do you notice this message? Why I'm going to writing this now? Here say this is the thread and say this is the completed, because our while loop is this is the completed. Okay, and you notice here you found our thread started and completed. What is this? Okay, I written something wrong. What is the problem here? I'm the wrong place. Let me control that. Okay, now it's okay. And he okay, okay. I got wrongly I do it. Okay, I have to do inside after here, not the while loop, right? Completed. And here say consumer also after while loop, right here? Completed. Consumer. And if you run, you notice our both threads are completed. Due to that, I'm not getting output, right? Notice both threads are completed. This is completed and this is completed. So first objective, both threads are in the running stage. First our objective, both are running. This is always running. This is always running, right? They're not going to stop. I don't know when they write, they read. Write, they read. Write, they read. Right? This is the objective. So
Right.
first say how to say infinite. Somehow you say let's say just true. True. True means always infinite. Always you run, right? And here I have to uh, if let's this flag, if this is the true, that means I'm going to read, right? And if it is a false, it is a true, that means ki I'm going to read data. Okay, if flag is true, I'm going to read data, and after reading I have to inform. Else else I have to say, hey, this flag is a this flag say equal to false, right? So here say ki I am read data. Once reading done, if I'm not reading, I'm false. False means here say producer say it's a false. Here also write this code, and true always run. Okay, and here say if this data is true, means data is the equal to false, then I am going to write value. eh? Else I not do anything. Okay, here just I'm writing false. I'm going to write value and setting the true, right?
Right.
If it's still this is the false, someone not consume, still I'm not doing. Until I'm not getting false, I'm not writing data, right? And once I write data, I'm say consume. So what this say? Okay, not equal to, they say right. Generally whenever writing this code, compiler say can you write the just in this way, simplify version this way, right? And we are simply here. So notice what we are doing. Simply here say just say like simplified version you can, else is not needed, right? Here simply say ki once I read value, it's the true I read, and after that I can say it should be false, right?
Right.
This is my objective. My objective is what? This is the one flag. If this is the false, okay, then producer is going to write data here and say it's a true, right? And consumer, let's if it is a true, read data and again say it's a false, right? So in each false case, they are going to write data. In each case, they are going to read true, right?
Right.
So this is the way we are controlling, and let's run it. Okay. Now this is going to, because this is a while loop, infinite loop. So intelligence very sufficient. So this is a while loop. Never this code is going to execute, right? This is unreachable code. This is known as a unreachable code. So you have to, as of now, let's comment out, right? This is the unreachable code. Clear? Why? Because this is a while loop, means always true, right? And this could never execute, so it would be comment out, right? So what is happening? Producer producing data, and where the consumer? Producer started, consumer data say producer produced data, and after that I'm something doing wrong. Let's do producer. Here the producer say कि while true always true. Initially this value false. Their right value it become a true. Whenever this will thread get a chance, this will thread get a chance. If true value, then print the value and set a false, and still wait. So going for the next. So let me just, this would be run, right? This here, let's say I am just writing this message inside the while loop, right? I'm just checking this thread is going or not, and what is the value of this flag, right? Just here say, okay, what is the value of flag, right? Same here, just ensuring that I'm going to write here. Okay. So here consumer. This while loop going on. My assumption is this is going on. Somehow some this set value true or false. Somehow both are not communicating. Because here I'm not using till now any synchronization. This notice here, they are always value true false. Okay, somehow what they are producing, they are something very fast response. Let's be I'm add some sleep here, right? Something sleeping, right? So they are, I'm just say once this done, let's producer is producing data, retain data, and after that I'm going to the thread dot sleep, right? Little bit. Thread dot thread dot sleep, okay? Thread dot sleep. And just set duration of second, let's see, 3 seconds, okay? Yeah, 2 seconds. And here set try catch, let's do try catch. Okay. So this is the was one way just make the both threads are safe. 2 seconds sleeping. This is also 2 seconds sleeping. Okay. Just mention going to sleep. Okay. This is the going to sleep. Okay. This thread going to sleep, and let me this thread also going to sleep. Mention the just same login. Data done produce and produce and going to sleep. Going to and test. So now they are now they are producing 100, 101 consume. Now notice producer produce, consumer consuming. Notice here. Let me just comment out all these things. So 405 produce and consumer consume, right? Notice. Let me light time little bit increase so that we can uh, instead of 2 and I say just uh, 3, right? Little bit. I'm just going to stop this line. And similarly here, I'm comment out this line and simply say this is about 3 seconds, right? So let's look the output. Producer and consumer, they are producing or not, right? And let's run. So I'm just make some gap between. Notice here, producer produce 100, consumer consume 100, right? Producer produce 101, consumer consume 101, right? Producer produce 102, right? Is it clear going on?
Yeah.
So let me again Just comment other the line. I'm not going to just say here. Just as of now, I'm just commenting all the logger message. Just producer consumer. Okay, and this was also very so. So in this way, what we are doing? We are logically communicating thread using some flag variable. Notice here, producer produce 100, consumer consume. Producer produce 101, consumer consume 101, right? Producer
Yeah.
produce, consumer consume. Producer produce, consumer consume. This
Okay.
way, both threads are communicating each other smoothly. They are written in form, written in form, written in form, right?
Right.
They are infinitely producer consumer problem going on. Properly, they are producing 109, consumer consuming 109, right? Producer
But
producing 1010, consumer consuming 1010, right?
but this is not considered a infinite loop, right?
This is the infinite loop. This program always run. Notice my
Hmm.
program is still going on. They are never stop because we design such program कि both threads are started and they are writing some data here, okay, and they are reading data, and again they are writing, again reading, again
Hmm.
writing, again. This is
Okay,
the
okay. So
infinite.
so it is the infinite loop,
Yes. Notice our application is still going on. Notice here, 120
right?
will produce and consume.
So
Notice,
threads are always listening.
depend upon the way you are writing code, right? You decide
Oh,
na ki what your thread going to do. Now this
okay.
program is never terminate, always be going to run, right?
Mm,
Notice here,
right.
our JVM project is still going on. We have to stop, then manually we have to stop them, right? So let me go just say five. This is a 5 second gap, 5 second gap, so that we can observe output, right? So what
Right.
we did here, we are simply saying this is my thread one. I am decided that these threads are never going to stop, right? Because they have to do produce data. So what say, hey producer, produce data and set flag false. This flag say, कि, hey, I am going to say other thread. They have thread one. This is the thread one, and this is thread two, right?
Yeah.
This is my flag and data, right? This is a two part. One is the flag, one is the data, right?
Right.
So here say कि flag false. Yes, first time false. So this they are going to write data. They are going to thread write data here, write data, and say कि now I am going to say flag true. I am saying is the true, and after that they are going here and waiting because this is a false. They are again waiting. Now it's a while loop going on. While loop always here going on, right? They are wait
Right.
something and again come while loop. Again check flag is set by false or not, because false is set by my this thread. Once this thread get a chance, this read value and say कि this is the false, right? And now this will come, it's false, and set data and print again change value. So in this way they are writing data and setting flag true. This is the true, but this thread again going to run. The next time come, it's a false, not false. Again they are waiting and again trying. This loop again waiting here, flag, right? In while loop. Similarly, this thread say, I am going to read in this flag. If this is the false, I am just waiting and not doing anything. I am just inside loop. Just whenever this set flag true, okay, that means someone written data. I am going to read value and again say false. Right here say this thread say, I am going to, if value true, I am going to read data and set a false, and after that I'm waiting some time, and again while loop say, hey, again check the data flag. If it's still flag false or true, if it's still false, don't do, just wait, don't do, whenever true, print the value, right? So in this way you are communicating two threads. Notice producer produce 100 and wait. Now consumer thread get a chance as a consume, and again consumer going to the wait. Producer produce data, right? Consumer again consume data, producer produce, right? In this way, producer and consumer, those are producing data, consuming data. Producing means here what we achieve. Here we are able to properly able to communicate these threads at to the this thread, right? How? Via this middleware object. One thread say, hey, I done. Okay, say, let's say I read. This say I done, let's you write, again you write. Let's I done, you write. In this way communication happen, right? It is clear, any doubt?
Yeah.
Multi-threading, due to that we have to set up some infrastructure according to our situation. Some now I am run this program. This program is run infinite, producer producing data, consumer consuming data. If you want to make some break, I want to, let's key after a specific value I want to stop the thread, right? I can write the condition. Let's stop. Here say, whenever, let us example, whenever I here you can write the condition. Here, here like let's we check the one. If this uh, value, like here, if this value become, let's greater than 120, let's 110, right? After 110, I want to break this loop, right? You say break. Clear? So whenever this value going to 110, this loop going to break, right? It's clear.
Yeah.
Break means you are going to outside of loop. Our outside loop is then thread automatic completed, right? So this is the, you, this way you are say, similarly here you also say if producer also going to stop, they once they produce data like 110. Whenever they data produce 110, after that their break. Break means going to out the loop, right? Out the loop our main thread color. So now if you run in this case, our thread is only run where, oh, greater than or equal to this way, right? While talking, what I am writing, I am not looking, right? So let's check. So all the things as a programmer, now notice our thread is started. Now our program is not is running. They are going to run till 110, right? To
So they're running in a which pair?
condition we have added until the value not produced or consumed by uh, greater than 110. Means ki 110s are produced here, right? After
Right.
111, both are going to stop. Now here I'm not going to stop. I say our program is run for only specific day, specific time, specific value, whatever you decide, right? So
Mm,
notice data produced by producer 7, consumer motors are produced, and now data 8 is produced, and both are waiting. 9 8 is consumed, 9 is produced, 3 seconds later 9 consumed, 10 is produced, and 10 is consumed. Now both application stops. My thread is start automatic, right? Now
correct.
all stop. So in this way, you have to decide how many times our thread going on. So here properly, producer produce data 100, consumer consume, right? Producer 101, consumer consume 100. So is it any confusion?
I got it.
So here just we are logically decide how our this producer consumer threads are going to produce data, consumer going to consume, right?
Right.
So here you notice as a programmatically, I'm not writing any new thing. While loop, if loop, set method, get method, all a basic programming. But objective is particular use case to meet, right? Is it clear? Here I am
Yeah.
creating one shared variable and passing the same data. I created one producer thread, consumer threads, and both are the started. Just this is the main method. Main method, nothing doing. And now all the codes written in my run method here, right? Producer what do and consumer what do. And now he notice whenever, let's say I reduce this time 2 seconds. Okay. So whenever you run this code, now in this case, don't worry, your producer start first or consumer start first. If producer start producing, if consumer take a first chance, consumer going to the wait, right? Because we written such code. Let's key our consumer take a first chance to run. So if consumer, this is my consumer, okay? This is my consumer. If let's consumer get a chance to first run, they come while loop. This flag is a false. False means don't do anything. Just sleep for 2 seconds. Okay. Once your 2 second come, again come here and let's again check the flag. If still flag is false, just sleep. Here we are ensuring that our always producer produce data, then consumer consume, right? How to
Right.
ensure it? Because using this flag concept. This why? Because why this both? Because this thread and this thread both have a same data object, right? Both
Right.
have a same data object. This value this can be read, this value this can be read. So this is the flag variable. Okay. If this is the true, that means here they are going to read value, right? If this is
Right.
the true, that means here is the waiting. Because right, once he reads value, then say I'm going to check the as a false, right? He say "Ki I am waiting, let's check the value. Oh, it's a false, means I have to write data. They am going to write data. They write and change the true, right? The here say ki whenever value false, whenever value false, I am going to write data. He say ki whenever value true, I am going to read value, right?
Right.
Both are in a while loop. A while loop until the value not true, I am just waiting. True, I am reading value and change the flag. In this way, this is a shared data object which say two threads are communicate to each other. So whenever two threads are communicating to each other, they need some middleware, right? That middleware is Java object.
Java object.
This is the data is the Java object, right? Here
Right.
our example, right?
Mm.
So is it clear how two threads are communicate to each other? This is the very famous problem producer and consumer. This is the implemented by the different approach. Today I just use the simple flag concept so that easily can understand, right? This
Right.
is the different way using the synchronized keyword, using the lock interface, using the blocking queue, lots of advanced things available to meet the same objective. Producer produce data, consumer consume data, right?
Two-way communication.
Yeah, means ki thread communication.
Thread
Thread one
communication.
communicate to another threads. How this thread inform ki I have done, right? How this thread
Right.
I receive and I completed my job. So they need some middleware, right?
Right.
That is read by this thread, that is read by this thread, right? So this is the very simple way implementation of two threads are communicating to each other by a simple one variable flag, right? One data object. Notice here I'm not using any synchronization, I'm not using any lock, just using the concept of basic programming approach, right?
Right.
Here we have to decide ki when our thread going to stop. That's our program responsibility. Notice in the case of whenever you're building a server, server never starts. Server always run in this while loop until someone is not saying, hey, going to the kill, right? Similarly, you decide your program is run till how many number of time, how many number of days, how many number of year, right?
Right.
So notice here, whenever you run, might be this two thread started, but still main can do. Maybe here I have written some program like let's print 100 number, right? That's out. This thread also our work going. Let's say I say here say, hey int stream dot range. I want to say 1 to 100, okay, and just say dot for each system dot out dot println, right? So notice both threads also doing my thread also doing work. Here my thread uh, main main thread uh, doing his own work, his own work, right? So what he did here say ki just main thread just started two thread. Your responsibility to do your work. I am free for doing my own work, right?
Right.
If you run here work, run the code, three threads are doing its own work, not interfering to each other. Notice here notice main is started, main doing his own work, right? Let
Right.
I add some sleep here, right? Okay, good option here. I am going to add some sleeping right here. Hey, whatever the number we have, say here, say number, uh, question mark here, say S out number, and just say similarly thread dot sleep. Just simulate the situation, right?
Right.
Let's key random duration of 2 seconds, right? Duration of 2 seconds. Let's and here say try catch. Okay, and I on doing main thread, doing by painting by and person and the thread dot current thread dot get name, right? So
Right.
notice here I'm trying to say ki all three thread is started, three are doing his own business. Notice main is printing one something, producer consuming, main is printing, right?
Right.
All is doing their own work, right? They are independently. So this is the three threads are not dependent to each other. Three are working differently. Notice here, all are working. Main thread going, producer going, consumer going, all three getting chance and work, right?
Right.
So notice producer consumer has completed job, still our main is going on, right?
Right.
So this is the way all things is as expected, right? Until all threads are not done, your program is still running. Notice my main thread is until printing 100, right? It will take time, right? Because I written
Right.
100 here. Let's say stops and just set a 10, right?
So you use in stream example.
Here you can use manually for loop, while loop. Just I am using the multiple flavor. Here just purpose run 1 to 10 number, right? For loop,
Right.
right?
Hmm.
And just printing on number, just waiting for some time so that I can visualize output. Main is also going on in parallelly. This is also going on. So this is not meaning ki main is just after completion of this, after completion of this again then main going to do. Main just is here main started here say main thread started. Main thread is started. They are creating this object, creating two threads, and doing his own work. Now this thread parallelly also doing his own work, right?
Right.
So this is the multi-threading, means multiple code are executing same time, right? Here main method also executing, producer code also executing, and consumer code also executing, right?
Right.
Here this code also going to execute simultaneously this producer code also going to run simultaneously, this consumer code also going to execute, right? Three codes are executed simultaneously by three thread. This is only possible due to the multi-threading, right?
Right.
Multiple threads. If there is no multiple thread, means ki only one thread, that means ki only one thread. First, if you're not writing a threading, then all going to the sequentially. Let's example. Here, let's say I'm not write the thread. I'm not writing this thread, right? What happen? I simply say producer dot not just run method, right? Run. Let's say start, right? Here say
Right.
let's say start. I'm not going to start thread. I'm just run. So now this is only one thread going all the things, right? Let's run. So notice first main started this, then doing this work, then doing this work. Notice your main started just going to the producer, just producing all the things. Problem, they are blocked because consumer is not going to consume, right? The logic we written, right? Here, the logic we written here, producer is producing data one, right? After that, they are waiting someone consume, right? So
Right.
we have to stick this name, then they are going to run, right? As of now, just I let's modify this code. As of now, just I uh how to say, I just comment this break if condition, right? As of now, for your let's I just comment out this if, right, where we are blocking ourselves, right? Now code
Right.
is okay. And so let's look the output. So the way you are writing code, the way you are running. Now producer is first main started, then producer first produce all the one train, then consumer going to 10 complete, right? Producer producing 10 value, right?
Right.
and they are completed 8, 9, 10. Then producer complete his jobs. Then again, notice your main is started. Consumer consumes and producer is finally main going. So sequentially they are going to run one by one, right?
But in this example, only producer produced, no consumer.
Then the producer produce and consumer can consume. Consumer consume because consumer can have only one will last value, right?
Okay, okay.
Because that we have data only one data object, na. So whatever the value written, they consume here, consumer, right?
Right.
Last value. So in this way, without multi-threading, sequentially all the one by one, all the code. First main is started, producer is started, consumer completed, again main is doing own work. So this is the due to the single threaded application, right?
Oh,
And
how did you mention the last, the consumer consume the last value?
here, notice our data, we have only data object that have only one variable value, right?
Right,
Let's producer start producing first 100 value, right? They are
right,
written 100 here, and no consumer started to consume value, right? Because consumer is not a thread, because it is only one thread is going to run. So now they start writing 102 value. So here value change 102. Next 10 value 3, 10 104. Because 10 time I run the loop. The last value 1110 I am written here, right?
right,
Our producer code completed. Then I started consumer run. Consumer go and read the value, last value 1010, read value and done, because there is no any other value to read. Here there is a, because here whenever read the value, last value is find the 110, right?
right,
Just go out and consumer close the call, right? In this way, this is the, if you writing this code, this is the sequential code, single threaded, only main threads are doing all the jobs. Notice if you run the program, all that is done by main thread, right?
right.
If you run this code, notice the thread name. Okay, something I again comment out. Control Y kahan? So notice here, all this done by only main thread. Thread name, notice main. Producer thread also, what the work done by main thread? Only code written producer was done by main thread, right? Notice
Mm-hmm.
all the activities done by only main thread, because this is only one single thread application. Notice all the output is just given in the main thread, main, right? Because they have not, we have not started any by default. Java is a single threaded application. Sequential of execution. Notice this
That
is
means one method, only main method is running.
main method and main thread.
Main thread is running.
Because this code is written in the different method. Notice run method, right?
Okay, okay,
The
yeah,
run
yeah.
method, not the main
Mm,
method code. This is the thread name. Okay. This is
okay,
what is your, this is the line here, current thread name, right? This is
okay,
thread
okay,
name.
yeah, yeah, yeah.
This is not main. So this is the way. So I am saying no, I want to multiple thread. So here the logic we have to change, because we have to written the logic to wait a block, right? We have to unblock.
Right,
And we have to say here, I'm going to start multi-threading, not just run method, right? Here you say no, it should be start thread, not run, not method call. So whenever you say this is the start, now here two threads is started separately, right? And now if you run the code, the same program now is produced continuously by the different thread. Notice this is the main thread, this is the producer thread, this is the consumer thread, right? This is the main thread,
right.
producer thread, consumer thread. So notice the code, this line is tell the name of the thread which are printing this line, right? It's makes sense.
Yeah,
So your, this is the example of your producer consumer concept implemented by the two thread multi-thread.
right.
Let's go, and lots of complexity here, but
Yeah,
I'm just try as simple as possible so that you can understand, right?
right, right.
Here complete business logically we have to think how our thread communicate, how wait, how stop, how resume, all the things we written from code itself, right?
Mhm.
In the later example, we create this code very simple using the existing Java library. Very simple. There is no manually you can set the flag true, false, automatic. This is the provided by the your lock object, right? Here I'm
Right,
not taking any lock object. This activity is automatic done by your locking object. Initially, whenever we are going to understand, we have to understand the basic things, right? So that we can understand the concept how thread communicate, how threads work.
right.
I think it's good for the day from my side. Anything you have?
Yeah. So I'm gonna have to like review this one
Yeah.
once again, and yeah, I think it's good for the day.
Yes, whenever time. But
Yeah,
this are the very, very you can say complex things are
yeah.
very, very simple thing as per the depend upon our understanding and familiarity, right?
Right, right, right.
Okay, so take care.
Take care.
Bye.
Yeah. Thank you.